Okay, this is kind of a tough one, but let's go through it and see where we come up. I'm asking you to find the volume. And this is a prime example of why I've defined the volume to be the area of a base times a distance or a height or whatever you want to call it. In this case, the base is this funny shape here on the end. Now, finding its area is going to be tough, but not impossible. First thing I'm going to do is I'm going to break this half circle off here. Then I'm going to cut a rectangle off here. The next piece is the piece that would puzzle a lot of people. I'm going to go out like this and make a rectangle like that. Why? Well, because these are quarter circles, and the only way I can find those areas is to subtract them out of something. I mean, I could make a square like this and subtract the quarter circle out of the square, but why not just make it one big rectangle? So I have 4 pieces here I'm going to find, and then I'm going to subtract out those 2 quarter circles. So my first piece up here is that half circle. That's going to be pi times 8 squared over 2, which is about 100.48 square inches, correct? Okay. Piece 2 here is a 10-inch by what rectangle? By 16. 8 and 8 make 16. So that is 160 square inches. Next, this is 16 plus 6 plus 6 is 28 by, well, 10 plus 6 is 16, which is going to give me what? 448? Does that sound right? And then I've got this 4th piece down here, which is 28 by 10 divided by 2, or 140 square inches. So I add those all up, and I have 848.48. Does that look correct? Well, I haven't subtracted yet. I've got to subtract quarter circles, so I might be really close to that. Is that what everybody comes up with? Yes, no? Okay. So now I've got to subtract out the quarter circles. What I'm going to actually do is I'm going to put them together and make one half circle. So that area is going to be pi times 6 squared divided by 2. 56.52. So when we subtract that out, I do get 7091.96. Is that what you had? Yeah. 792? Close enough. So that is the area of the base. So now to find the volume, it is simply that area, 791.96 inches squared times this distance from base to base, which is 30 inches. So 23,758.80. That is square or cubic inches. If I wanted to convert that to cubic feet, what would I do? Would I divide by 12? No. I would divide by 1728. 144 would be square feet to square inches. 1,720 is 12 times 12 times 12. So that would give us 13.75 basically square or cubic feet from cubic inches. I didn't ask you to do that part. That was just a little extra. Yes, sir. Came up with a different answer? Well, did something wrong. What'd you have for the area of the base?
833.07.
So that would be their problem. Well, something was off there.
I got the right area for the bottom triangle and for the top circle and top half circle and top box.
So you got this and this right?
Yep.
And then this here.
Yep.
So it's just this piece?
Yep. Where you took and made a large box.
Yep.
I took and made a rectangle that was 10 inches by 28 inches. I made a rectangle that was 16 inches by 6 inches.
Okay.
And
let's take a look at what would happen. So you've got 10 by 28, right? Which is 280. You got 16 by 6, which is 96, right? So far that is 376. And we're going to add to that. Now remember, this is 448 minus the 556.52.
Right.
So technically that's what, 391 something, 391.48, I believe, is what we're really shooting for there. So we're at 376. We've got to figure out how to make that up. Well, what I'm going to do is I'm going to do this. I'm going to put this into a rectangle that's 12 by 6.
I found the area of the circle and divided it by 4.
Yeah, but the problem is the area of the circle is missing. It's not there.
You can find.
We don't want the area of the circle. We want the area of the square that's left outside the circle. And I can find it piece by piece and double it. Yeah. So let's do that. So I've got a box that's 6 by 6, which is 36. Then I have that quarter circle, which is pi times 6 squared divided by 4, which is what, 9 times pi? So 28.26. So we subtract that to get a difference of 7.74 times 2 is going to be 15.48, which adds up to 391.48, which is our magic number.
I see what I did wrong.
Yeah, you added in the quarter circle instead of finding the square and subtracting out the quarter circle. Good stuff.
Good stuff.
Now, I'm going to actually leave a blank spot here. So in your notes, leave like half a page or so. We're going to come back to that shape in a little bit. That's what you wanted to hear, right? Yeah. Did you want to draw it in your notes again? Okay. I was lucky I was able to draw it the first time. Anyway, we've been talking about volume. And we started out with volume of a box. Now we defined our volume with the area of a base. So let's say that we've got a base here that is 6 inches by 10 inches. So the area of the base is 10 by 6 or 60 square inches. Then we move that base through a distance, sometimes called the height, sometimes just a distance, a depth, or whatever. Let's say that is 8 inches here. So the volume was then found by taking the area of that base times that height of 8 inches. So in this case, 480 cubic inches. And we just saw in that opening example that strategy of finding the area of the base and then multiplying by a distance makes it so we can find the volume of pretty much any regular shape. This, by the way, is what's called a prism. It's a prism because there is a shape that is pulled through the whole object, no matter how irregular it is. And this one's extremely irregular. This shape that we found the area of, that base, slides through the whole object. The whole object is based off of that shape. Well, any box is a prism because actually I could pick any side to be the base. We used the bottom here as the base. But we could actually pick any side to be the base because you could take any of those rectangles and pull it through the whole object. Well, the next thing we want to talk about today is something called surface area. And surface area is adding up all of the surfaces, finding the area of all the surfaces and adding them up. Now for a box like this, it's just 6 rectangles, and they come in pairs. Like the bottom and the top have the same area, they're the same rectangle. Front and back, left and right sides. So we could just find the areas of the rectangles and add them up, all 6 of them. That's what we're going to do, yep. But we're going to divide the surface area into 2 pieces. Surface area is going to be the area of the bases. Notice I put the S on the bases in parentheses because we're going to look at some shapes that only have one base. Plus something we're going to call the lateral area. But the lateral area is the area that connects the bases. So in this one, we've got the base on the bottom. We've got the base on the top here. Is the second base. It's identical to the bottom. The lateral area is this area that wraps around the 4 sides that connect the bases together. Now I could find, since this is just a box, I could find individual areas for each of those rectangles. But I'm inherently lazy and I want to find a shorter way to do it. And I want to find the way that's going to work for pretty much any shape. So what I'm going to do is I'm going to slice that up the side right there and I'm going to fold it out. And what I'm going to get is I get a rectangle here that's 10 by 8. But then this side folds out and I get another rectangle there that's 6 by 8. Then on the back, that one folds out and I get a rectangle that's 10 by 8 again. Then I get this end over here that folds out and I get a 6 by 8. So what I've done is I've taken all 4 of those rectangles that make up the lateral surface, the surfaces that connect the bases, and I've folded it out into one long rectangle. The height of this rectangle is still just the height of the box, the 8 inches. The length of this rectangle is the 10 plus 6 plus 10 plus 6, or simply the perimeter of the base. So the lateral area, abbreviated LA, is equal to the perimeter of the base times that height, or that distance. So for this box here, the perimeter of the base, 10, well, let's add it up, perimeter of the base, 10 inches plus 6 inches plus 10 inches plus 6 inches is 32 inches. Therefore, the lateral area is 32 inches times a height of 8 inches, or 256 inches squared. So what does that mean? That means our surface area sometimes called total surface area, is going to equal the area of the bases. We said the base was 10 by 6. That was 60 square inches, if you remember. We had to figure that out to find our volume up here. Area of the base. Well, there's a second base, so plus another 60 square inches, plus the lateral area of 256 square inches equals 376 square inches. That is our total surface area. Area of the bases plus the lateral area. What do you think? Better than sharp stick in the eye? Not by much. In your notes, I'm going to have you try a simple one here. find volume, lateral area, and surface area, total surface area. So, to find the volume, first step is to find the area of the base. I'm going to use the bottom as the base. So 12 inches by 9 inches is 108 square inches. How many of you found that? Okay, so that means to find the volume, 108 square inches times 10 inches is 1,080 cubic inches. How many had that as the volume? Perfect. So we're sweeping the field so far. For surface area, we'll start out with the lateral area. And to find the lateral area, the first thing we need is the perimeter of the base. So the perimeter of the base is 12 inches plus 9 inches plus 12 inches plus 9 inches, otherwise known as 42 inches. So that makes the lateral area, the perimeter of the base, 42 inches times the height of 10 inches, 420 square inches. How many of you had that? Cool. So that means total surface area, or just surface area, is the area of the base, 108, plus the area of another base, 108, plus the lateral area of 420, otherwise known as 636 inches squared. How many of you had that? Oh, doing well. I'm happy. We're going to go back to that. Don't worry.
Yeah.
Find volume, lateral area, and surface area. I'll give you a couple minutes. First of all, what's going to be the base of this? The triangle. So the area of my base be 10 inches by 24 inches divided by 2 because it is a triangle. So 120 square inches. Making my volume, the area of that base, 120 square inches, times the 30 inches between bases, otherwise known as 3,600 cubic inches. How many of you had that for the volume? Forgot to divide by 2? Did you guys see what you did wrong, for those of you that didn't get it? Feel confused, Bruce? Where did I lose you?
What you chose is
Okay, well, it's not on bottom, but that's the one shape that I can pull through the whole object. The base is always the shape that if you slice the object, you can slice it anywhere parallel to that surface, and you'll get that same shape. So if I slice it across here, I'm always going to get that triangle. If I slice it the other way, any other way, I'm not going to get a shape that's, I mean, if I tried to slice it across this way, I'll get a rectangle, but it won't be the same rectangle as the bottom. Or the other way to think about it is, in order to make this object, I took that triangle and I had to pull it through space. And what it traced out through space is the object. So that's my volume. Now for lateral area, I first must find the perimeter of the base. To do that, I must find this side here, which is going to be 10 squared plus 24 squared equals c squared, which will give me that is 26 inches. I'm going to assume you guys can do that. So the perimeter of my base is 24 plus 10 plus 26, otherwise known as 60 inches. So my lateral area is that perimeter of the base, 60 inches, times that same height or distance again of 30 inches, giving me 1,800 square inches. So my total surface area is the area of the base, 120, plus the other base, 120, plus the lateral area of 1,800 square inches, which gives me a total of 2,040 square inches of total surface area. Why do I do it this way? Why do I define a lateral area instead of just finding the... I could have done the same thing here. This is 24 by 30 is this rectangle on bottom. This is 10 by 30. This is 26 by 30. I could have just found rectangles and added them together. Why do I define a lateral area as being a perimeter of a base and then times the height? Well, because we have some things that don't have rectangular sides. Pretend those are circles. Of course, finding the volume of this is pretty simple. We just find the area of the base, which is pi times 4 squared, or 50.12 square inches. So therefore the volume is that 50.12 square inches times the height of 10 inches, give me 501.2 cubic inches. That, easy enough to do. We did that a little bit yesterday. The lateral area requires that we have the perimeter of the base. In this case, the perimeter of the base is just the circumference of the circle. So it's pi times 8, otherwise known as 25 point. This should have been 0.24, shouldn't it? That should have been 502.4. 25.12 inches is the circumference, or the perimeter of the base. So once we've got that circumference or the perimeter of the base, the lateral area, just like before. Because what that's saying is this, if I cut this down the side, I can roll this out, and all I do is get a rectangle that still has a height of 10 inches, and the base of that rectangle is just the circumference around the circle. I'm rolling out the sides of that cylinder to make a rectangle. So my lateral area is the perimeter or circumference of that circle, 25.12 inches times the height of 10 inches, give me 251.2 inches squared is my lateral area. So that my total surface area is the 50.24 for the area of my base, plus a 50, that's the bottom circle, plus a 50.24 square inches for my other base, the top circle, plus the 251.2 square inches for the lateral area, the rectangle that wraps around the edges, giving me 351.68 square inches total surface area. See how easy that is? So our cylinders don't require any sort of special formula. It's the exact same process. Perimeter of the base. The difference is the perimeter of the base is the circumference. Now, we let the fun start. I told you to leave some blank space here. We've already found the area of the base. 791.96 square inches. We're going to need 2 of those for our surface area. Now we need the perimeter of our base. Well, I'm going to add up the straight sides first. I've got 10, 10, 10, and 10. So I know those to be center of my base. 10, 10, 10, and 10. Those are my straight sides. I can find the slope side here. If this is 10, this was 26 all the way, or this was a 28 all the way across, this is 14. So that's going to be the square root of 10 squared plus 14 squared, right? A squared plus B squared equals C squared. You're correct, 17.2. So 17.2 plus another 17.2, because there's one over here too. And then this will be half of the circumference of a circle that has a diameter of 8. So that's pi, or the diameter of 16, I should say. Pi times 16 divided by 2, 25.12. The other one is half the circumference of a circle with a diameter of 12. The radius of each of those quarter circles is 6. So it's a diameter of 12, and I'm only divided by 2 because 2 quarter circles make a half circle. So that's what? 18 point what? 1884. That's with the pi key? Okay. We'll use 18.84. That's what's it going to hurt. So we're going to add all those up. And what do we have? 4396, 8396, 36. I get 10836. No. $83.96, 93, 103, 110, 117, 118.36. About inches. That's the perimeter of my base. So then the lateral area is the perimeter of the base times, that was 30 inches, I believe. Yep, between bases. Which is going to be what? Square inches. 3,550.8 square inches. That's the lateral area. So my total surface area is the area of my base, 791.96. Plus the area of the other base, 791.96. Plus the lateral area, 3550.8. It's going to give us 5134.72 square inches. That really, I mean, that shape was pretty ugly, but that process really wasn't that bad. We already had the area of the base from finding the volume. Finding the perimeter was just breaking it down into shapes, straight lines, hypotenuse of triangles, and arcs of circles. That's why I define things the way I do, with a volume being an area of a base times a height, and surface area being the area of the bases plus the lateral area. Because doing it that way, you can find the area of any shape as long as you can, or you can find the volume of any shape as long as you can find the area of that base. And you can find the surface area as long as you can find the perimeter of the base. In your textbook, on page, big book, 609 to 610. It's going to be exercise 28-4. I'll do 1 through 12. Just go do all of them, since we're having fun. Areas and volumes are a big deal, just so you know. We might do a few of them this semester.
You're going to put them up in my comment.